Hi everyone, this is the gas walkthrough for September 24th. I'm Philip Newman. Today I'm solving Double Nickels on the Dime by Bill Murphy. This is a double arrow Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some things that are not actually arrows. There are no arrows in this grid, but they're called double arrows because they work a lot like an arrow, in that the digits on the line sum to the digits, plural, in the circles. So there are 2 digits in these circles. The sum of those digits is the same as the sum of these 5 digits. And those are the rules, and we're going to get started with those longer outside lines. There are a couple of different ways you could look at this. One is just trying the highest digits in the circles and the lowest digits in the line, and that will work. But one trick for this particular setup is Bill has given us the 2 digits that are not on the line or in the circles, and they add up to 15. Since the entire box adds up to 45, the remaining cells are 30, and since these and these have the same sum, we can divide 30 by 2 to get that sum, which is 15. And the only way to do 15 in 5 cells is 1, 2, 3, 4, 5, and then we need 7, 8 in the 2 circle cells because 6 and 9 are used up. These aren't 3 and 4, so these are. This isn't 2, this isn't 5. Alright, same thing down here. Exactly the same given digits. So we can clean that up. This is not 4, this is not 5. Alright, up here we have digits summing to 11. So our remaining digits sum to 34. These are going to have to be 8 and 9 to get 17, and then these will be 1, 2, 3, 4, and 7 to get the other 17. And now this 1, 4 pair is looking over here. That's not 3, that's not 3, so this is 3. The 3 looks down here. The 1, 2 pair looks here. The 4 resolves to 3, 4. The 7 here resolves to 8, 7. This digit in the column is the 9. The 9 here already resolved that. Am I missing any? The 1, 2, 5 here resolves 7 and 2. And this is 9. Left over the 7, 8, still not resolved. We'll do this first. We might be able to get it looking at these. 13 means we have 32 left over. 32 divided by 2 is 16. The only way to do that is 7, 9, and we only have one way to arrange those with that 9 there. These are 1, 2, 3, 4, and 6. These aren't 2 and 3. The 3 here resolves to 3, places 2 there. The 1 in this triple resolves to 5 and the 1. This leftover digit is going to be 7 or 8, and we have an 8 here, so that's going to resolve our 7, 8 in box 1 that we started with. This is 6, because we have 1 and 4, our remaining digit is 7. And then the 2 resolves 1, 2, which resolves 4, and that is all of the digits in the corner boxes. So now we're going to look across at the rows and try and resolve those. We may have a lot of unresolved triples, we'll see. 5, 7, 8, this one is 5. Do get that digit because of the 7 and 8 here. These are 3, 4, 6. These are 5, 8, 9. This will be the 8 because of the 5, 9. Then we have 1, 4, 8 here. The 1 is placed. And we have 5, 6, 9 here. The 6 is placed from these. And that's also going to place a 3 there. This is 5, this is 9. Alright, let's look across this row. We have 2, 3, 6. This is not 2, and I see a 3, 6 pair here, so this is not 6. Anything else there? The 8 here resolves the 6, which resolves 5 and 8. Resolves the 9 and 5 here. That's not 6. Anything across here? We're going to need a 1 here somewhere. That's not 6 either. Alright, this is 1, 7, 9. That is going to place a 9 there. 1, 7 there. Okay, let's look at these lines. Holding off on looking at these lines as long as possible, but we are there now. The highest digit we have left in this column is 6. We definitely can't put 6 on the line. That would give us 15, and we've already used all of our high digits. So 6 is going to be in one of these cells. The next highest digit we have available, we have 1, 2, 4, and 6. If we put anything lower than 4, 6, we're not going to be able to get above 9. So this has to be 1 to go with the 9 to make 10, and that is going to resolve these. This is 2, 3, or 4, not 3. So now this is 1 bigger than the 6, so this needs to be 1 bigger than this. It's going to look like that. Let's put sum to 9 now. 6, 2, 6, 4, 6, 3, 3, 4, and then 8, 7, 8, and 4 to finish it off. Really nice puzzle. The corner boxes resolve fairly quickly, a little bit of math, but then, of course, you have to use these to disambiguate at the end. I've mentioned this before fairly recently. Bill likes to set up where we have triples in these cells, and they're not necessarily resolved, and then use the central box to resolve them somehow. It's always very cool and satisfying. But this time we used the lines. So, hope you enjoyed that. Let us know how you did in the comments, and I will see you next time.